Hi, guys. Happy Thursday. So, taking a look at your responsibilities for today, you are going to go through this slideshow presentation using your workbooks, making sure to pause the video when asked and complete the problems independently. Then you are going to head on over to a end of lesson Google form. The last thing you need to do is to complete your iReady responsibilities, 15 minutes each day for a total of 1 hour by the end of the week. And as I explained to you guys previously, you are more than welcome to do all 60 minutes at once. However, you want to break it up, but by the end of the school day on Friday, you need to have a total of 60 minutes. All right. So here's a little thing that your fifth grade teachers made for you guys. I also included it in the lesson for today. There's a separate slideshow presentation for you. But again, here are all of your fifth grade teachers just letting you know how much you are missed. A reminder that today is my last day for scheduled Google Meets. I have to say that my Tuesday groups had a lot more participation than yesterday. I was so sad because Wednesday's groups, I only had one person from the morning and one person from the afternoon show up. And it was great that I had so much one on one time with those students, but I was really looking forward to seeing the rest of you. So, again, Thursday, you can see these are my top in the top group here is my first switch. And then down here for Thursday at 1:30, I will see my third switch students. Next week, you can expect the same kind of thing, guys. I'm going to create a schedule for meeting with everybody throughout the week. And you are expected to take a look at this schedule, let me know ahead of time if there's conflicts, and then show up to the meeting so that we can reconnect. All right, so here's our estimation activity. So you can see over here, I had some answers that were a little surprising, like 60, 95, or 100 of these cheese balls. If you were to look just at this front layer here, because this is kind of like a volume question, and we studied volume before, length times width times height. But if I look just right here, 1, 2, 3, 4, 5, 6, I kind of see 6 going across just this little part, not even talking about this extra. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, if I just do 6 times 12, that means that there are 72 cheese balls just in this front layer. So you can imagine that it's going to be kind of deep going backwards or wide, however you want to look at it. So again, I was a little surprised with how low the numbers were overall, actually, because if you remember, the very first time we did this, it was this container dumping out the cheese balls onto a cookie sheet. And I believe at that time, it was a number that was a little less than 300. And there were still more in the container. So let's take a look at the final answer here. So you can see that's the start of the very first one we did, 286. So another tray with 286 about. So we're at 575. That was tray 3. And then here we go with the last one. I like how this person is organizing the cheese balls in order to count them, and you'll see how they do it in a second, trying to make equal rows. You can see that. So the answer was 910 cheese balls in that container. And again, our winner with a low answer, like I was explaining before, Taylor, 591. So it is around 8 o'clock at night when I have recorded this video. So if you are somebody who submitted your work a little bit later and you were closer, I'm sorry that I missed it. But at the time, Taylor, you were the winner. So yay you. All right. So again, I told you guys you're going to need your workbooks today, so make sure that you have those handy as well as a pencil. And if you need your math notebooks, let's do that as well. Our standards are the same, where we're working with attributes and categorizing two-dimensional shapes, as well as now looking at how they fit into a hierarchy. Today we're working on the develop lesson. So earlier in the week, we did the explore lesson, which is that first day lesson where you're still really just kind of being introduced to the topic. And today we're going to start to talk about it a little bit more in depth. So at this time, please turn to page 591 to the develop lesson. And while you're doing that, I just want you to quietly review these vocabulary terms to yourself. You might want to push pause on the video so you have some extra time to read them. All right. So again, these terms are going to come up a lot in our geometry unit. So the first thing that we're going to take a look at is we are going to sort these shapes into the Venn diagram below to show the relationships among parallelograms, squares, rectangles, rhombuses, and quadrilaterals. Use at least one shape in each region of the diagram. Classify the shapes by labeling each region with the category name. So if you see in your workbooks, you have that blank Venn diagram below this problem. So I actually am going to give you the titles of each of those ovals, and then I'm going to ask you to go ahead and answer the question. So again, I just want to remind you that you are being asked in this problem to take the letters of the shapes, place them where they belong in the Venn diagram to show the relationships. So the first thing I want you to do is copy down the titles of each of these categories here. This outside oval is called quadrilaterals because it is the most general. Then you can see with the next oval, largest oval, says parallelograms. The reason why it's completely inside quadrilaterals is because every single parallelogram is a quadrilateral. Then here you can see rhombuses, squares, and rectangles. All three of these shapes are inside parallelograms because all three of these shapes are also parallelograms. All three of these shapes are also inside quadrilaterals. Therefore, these three shapes are also quadrilaterals. Now, I want you to notice this part in the middle, okay? So a square has all the same attributes as a rhombus. A square has also all the same attributes of a rectangle. So that's why it's overlapped, because squares are rhombuses and squares are rectangles. So what I want you to do now is push pause on the video, label the title of each of those categories within our Venn diagram, and then I want you to put the letters of the shapes where you think they belong. When you've completed the task, come back and push play and we'll go over it. All right. So the first thing that I like to do is we know that every single one of these shapes are quadrilaterals. So I like to start with the most specific and work my way to the most general because, again, this one here has all the attributes of everything else. So when attempting problems like this, my tip to you, start with the most specific and work your way out to the most general. So taking a look up here, which of these shapes, which of these letters is a square? Now, you should have had shape D because to be a square, you need all the attributes of a rectangle, a rhombus, a parallelogram, and a quadrilateral. Four-sided figure, opposite sides are parallel. We have all sides the same length, four right angles. So you could see that's where those other attributes came in. All right, so how about rectangles? Which of these letters are rectangles? You should have placed C and F, letter C and letter F. In order to be a rectangle, you have to have the qualifications of a parallelogram and a quadrilateral. Four-sided figure, opposite sides are parallel and opposite sides are the same length. But to be a rectangle, you have that specific attribute that you need four right angles. So now let's take a look at a rhombus. The definition of a rhombus is a shape that has 4 equal sides. So you can hear just by me saying 4 equal sides, you know it's a quadrilateral. And those 4 sides being equal also means that they are parallel to each other, the top and the bottom, the left and the right, as well as 4 sides equal mean that the top and the bottom and the left and the right are going to also be the same. So taking a look at these shapes, you should have put letter E right here. There's your rhombus. Now, a parallelogram is a little bit more general than these 3 terms. All of these shapes are also called parallelograms, but this one here, I'm looking for the shape that the only characteristics that it meets is that it has opposite sides that are parallel and opposite sides that are equal. And for that, you can see shape B. That's the only one that only has those 2 attributes. And then the last one is just shapes that are quadrilaterals. You should have had A and G. A and G are 4-sided figures, but they really don't have any other special attributes that allow us to put them in any other categories. All right. So I just kind of want to show you this here. This is the chart that I've been showing you all unit of geometry, but here you can see in your workbooks, if you look on the next page, how they break things down. So any shape with 4 sides, that's the property or attribute. Parallelograms, quadrilaterals, rectangles, rhombuses, squares. 2 pairs of parallel sides. All parallelograms have to have that property. Not all quadrilaterals, which we saw with that shape A from the other slide. Rectangles, rhombuses, and squares also have to have this property. 2 pairs of sides of equal length. So again, you can see parallelograms, rectangles, rhombuses, and squares all meet that property. And then here's where it starts to get a little bit different, because you can see up until this point, parallelograms, rectangles, rhombuses, and squares all meet these top 3 things. So now 4 sides of equal length, you can see that that's not checked off in the rectangle, but that is checked off, and that shows all the 4 properties that make a rhombus. And you can see, well, wait a second, the square has 1, 2, 3, those same 4 properties, and that's why a square is a rhombus. And then here it says 4 right angles. Well, that's why a square is also a rectangle, because it meets all those 1, 2, 3, 4 X's that a rectangle meets. So just kind of taking a look here, I just want to show you using arrows that all rhombuses are parallelograms. All rectangles are parallelograms. All squares are also called parallelograms. Now, the next one I want to just show you is that, well, squares are rectangles, and squares are also rhombuses, because a square is the most specific category we have with quadrilaterals. And I was really proud of the one student that I met with from the afternoon group who, when we were talking about geometry today, they told me that that was something that they took away from their lessons earlier in the week, that they realized that a square is the most specific because it meets all these other qualifications. All right. So let's take a look at number 1. It says, look at the quadrilaterals column in the table and the placement of shape A and G in the Venn diagram. Why are shapes A and G placed in the outermost oval? So I kind of talked about this already. And when they say, look at the column in the table, they're talking about this table right here, which you can easily see in your book. So looking at this qualification here. So this is just for you to reflect back on what I said. Why are shapes A and G placed in the outermost oval? Push pause, jot your answer down, come back and push play when you're ready. All right. So taking a look, A and G are in that outermost level, and here's just a sample answer. It's because quadrilaterals are the most general. The only property in the table that shapes A and G share with the other shapes is that it has 4 sides. That's it. So that's why it can't go in any other oval. All right. So I know that it's a little hard to see the two illustrations that I have here, but I wanted to include the Venn diagram and also this chart in order for you to answer question 2 and question B. I'm sorry, question 3. So question 2 says, explain how the Venn diagram supports this statement. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. So why is shape B considered a quadrilateral, but why are shapes A and G not parallelograms? And this here can help you looking at those properties of a parallelogram. Then for question 3, it says, look at the table. Which categories share all the properties listed for parallelograms? So which other categories of shapes share these 3 properties? And then I want you to tell me, well, how's that modeled in the Venn diagram? So again, I want you to organize your thinking, use the Venn diagram in the table, push pause on the video, and answer these questions. When you're ready, come back and push play. All right, so question 2, why are all parallelograms quadrilaterals, but not all quadrilaterals are parallelograms? So here is a sample answer for you. The oval of the parallelograms is inside the oval for quadrilaterals. A parallelogram has all the properties of a quadrilateral, and you can see that. It only needed to have that one box checked off. But a quadrilateral does not always have all the properties of a parallelogram. So again, all parallelograms are quadrilaterals, but not all quadrilaterals like shapes A and G can be considered parallelograms. So number 3 says, look at the table. Which categories share all the properties of a parallelogram? So which of these other categories at the top here share 1, 2, 3, those 3 properties? And we did talk about this on the other slide. So taking a look, you should have been able to figure out, well, a rectangle, a rhombus, and a square all have those same properties. And then we're going to talk about how is that shown in the Venn diagram, that a rectangle, a square, and a rhombus are all considered a parallelogram. That is because their ovals are completely inside the oval for the parallelogram. Now, I really want to make sure that you have these answers down in your workbook so that way you can use it on your exit ticket or when you're completing other assignments. So if you need to pause the video at any time to update your workbooks or jot things down in your notebooks, you can always do that during the video, or you can go back and find pieces of information that you want to re-listen to and re-watch. So take advantage of having a video to really gather the information that you need. All right. So I want you to go ahead now and answer 4 and 5. 4 and 5 say, look at the table. Which properties are not shared by rectangles and rhombuses? So what makes a rectangle and a rhombus different? How was that shown in the diagram? And then number 5 says, why is shape D inside all the ovals? Why is the square inside everything else? So again, I really talked about this back on this slide here with those arrows and this slide here when we were comparing these 2 tables. So you already have the answers that I'm looking for this last piece. And I'm asking you to kind of reflect on what I said and go ahead and jot those down. So go ahead now, push pause, answer 4 and 5, and come back when you're ready. All right, so number 4, which properties are not shared by rectangles and rhombuses? So they do share some, which you can see right here, but the only place where they're different is where there's an X, but not one here, and an X and not one there. So you should have had the 4 right angles and the 4 sides of equal length, because the 4 right angles are required for a rectangle, but not a rhombus, and the 4 sides of equal length make a shape a rhombus, but not a rectangle. So how is that shown in the diagram? The 2 ovals overlap, but one is not totally inside the other. And this is really important because last week we weren't really looking at these overlapping ovals. We were looking at ones inside the other ones. That is because sometimes a shape can be both a rhombus and a rectangle, and sometimes a shape can be only a rhombus or only a rectangle. So why is D inside all the ovals? Well, that's because a square has the most properties. It's the most specific. It's a subcategory of everything else. And there's that vocabulary word that we've been working on for 2 weeks. So this completes our workbook portion of our lesson today. Again, go back and watch the video if you're unclear about anything, or please write me an email if you have any questions. The last thing I need you to do is submit your presentation, or it could have a turn-in button, and complete the Google form that goes along with today's lesson. Please do not rush through the Google form. Try your best and have a great Thursday. And I look forward to seeing so many of you today.